a topic called implicit differentiation. So it's a different way to take derivatives. So far, all the derivatives that we have done are what are called explicit derivatives. So we can get one variable. We can get everything in terms of one variable and take the derivative. Today, we're going to take a look at ones where we can't get a variable by itself. Okay. And how do we work through that? How do we find that derivative when we're dealing with multiple variables? That's called implicit because we're not able to get in just terms of one variable. Okay. Think about the function. Oops, not 5. X squared plus y squared equals 25. Okay. We can't get that in terms of one variable. If we try to solve for, say, y, which is what we're used to y equals or f of x equals. If we try to solve for y, we would have to take a square root and we would have therefore a positive or a negative, which we can't do that. We can't then take the derivative of that because we don't know what sign it is. And there's going to be functions where we can't even get y by itself, even with square roots and things like that. So let's go through how to do this. The big thing to remember for all of these problems is anytime you take the derivative of a y term, you're going to put in a dy dx with it. And let's talk about the reason why. Think about when you did chain rule. Okay, when you had chain rule, and you take derivative of f of u, you have to do f prime of u times u prime, right? So whenever we take the derivative of a y, because we're taking derivatives with respect to x when we're doing implicit, we have to put a dy dx every time. So we have to take the derivative of, we have a function, what's going on with my pen here? Whoa. Okay, if we have a function that's in terms of y, we have to take the derivative of that, and then we have to multiply by a dy dx. Okay, so let's take derivative. Let's look at this x squared plus y squared equals 25. If we have derivative of 2x, or excuse me, of x squared with regard to x, that's 2x. Derivative of y squared, now we're taking derivatives with respect to x, so derivative of y squared is 2y times dy dx. Again, we take the derivative and then we have to put in that extra piece. Equals derivative of 25, 0. Okay, now we want to simplify down and get dy dx by itself. So let's take a look here. We would subtract the 2x over, divide by 2y. So we can get rid of those 2's. 2 divided by 2 cancels out, and we could have an expression for dy dx that is negative x over y. We could then use this derivative as we have in the past. We could plug values into it to find slopes of tangent lines and so forth. Notice the only difference is we have two variables. So if we plug in a coordinate, we have to know the x and the y coordinate in order to be able to plug in, which is different from what we've done before. Before, we only needed the x coordinate. Now, we may need both coordinates when we're plugging in. Let's take a look at another one, and we'll actually go a step further. Let's say we're going to find the derivative at a specific value. So let's say we want to find the slope of the line tangent to the curve. If I could write that, that'd be great. xy plus y equals 8. At the point, let's say 1, 4. Okay, so we need to find derivative and then we need to plug in the value. Now, remember what we talked about when we did derivatives. We said when we take this derivative, we don't have to simplify it down, right? Same thing here. We're going to be able to take the derivative and then we don't have to really simplify down. We can just plug in our coordinates. Okay, so let's start. X times y, that's a product. So we're going to have to do product rule. So we start with first one, which is x. Maybe. What's going on with my pen? Okay, so we've got x times the derivative of y, which is just 1, but then we also need dy dx, plus the second one, y, times the derivative of the first. Derivative of x is just 1. And remember, we don't need anything special when we take a derivative of an x term because we're taking with respect to x. Plus, now take a look at our next term is a y. Derivative of y is 1, and then we need dy dx equals 0. Okay, because derivative of 8 is 0. Now, instead of trying to simplify this one down, we don't have to try to simplify it down because we don't care what the actual derivative expression is. We just care what the slope is. So we can go ahead and plug in. Let's plug in 1 for x and 4 for y. So 1 times dy dx plus y, which is 4, plus dy dx equals 0. Now let's start simplifying down. We want to get dy dx by itself. So 1 dy dx plus dy dx, that gives us 2 dy dx equals, move the 4 over, that's negative 4, divide by 2. And the slope at this point, negative 4 divided by 2 is negative 2. So the slope at the point 1, 4 is negative 2. Okay, so we can do it just like we've done before. There's just that added piece of every time you take a derivative of a y term, you have to put in the dy dx. Okay, let's try another one. Let's say that we want to find an expression for dy dx for the curve sine of xy equals 1. Okay, so let's start taking that derivative. This is a sine of u. So derivative of sine is a cosine of u times the derivative of what's inside. In order to do the derivative of x times y, that's a product rule. We already did that in the problem before. So x times derivative of y, which is dy dx, plus y times derivative of x, which is just 1. So there's our chain rule for sine of xy. We had cosine of xy, and now times the derivative of what's inside, which was x dy dx plus y, equals derivative of 1 is 0. Guys, I'm going to go ahead and tell you the biggest problem I see here. A lot of people forget to take that derivative, and they'll just write that constant down. For whatever reason, we know the derivative of a constant is 0, and that should happen every time, but a lot of times people will forget, and they will accidentally write that number as it is down. That's the biggest mistake that I end up seeing a lot. So now let's take a look from where we left off. First thing we got to do, let's get rid of that cosine of xy. It's multiplied by this entire thing, so we can divide both sides by cosine of xy. Okay, that's gone now. If we do that, take a look on the right-hand side. 0 divided by anything is still 0, right? So we just have x dy dx plus y equals 0. Subtract y, x dy dx equals negative y. Divide by x, and dy dx, our derivative, is negative y over x. Okay? Now again, that one, we were trying to find the expression for the derivative. So we did want to go ahead and simplify down. Sometimes we will not have to do that. Sometimes we'll just be plugging in to find the slope of a tangent line. So it really depends on the problem as to how far you have to go with this. Let's try another one where we're finding the slope of a tangent line, so we don't have to take it as far. Okay, let's say we want to find, I'm going to try to find a good one. Okay, let's say we want to find the slope of the line tangent to the curve 2x squared y minus y cubed equals 7 at the point 2, 1. Okay, now the nice thing is they did go ahead and give us the coordinates. Sometimes they won't, but if they don't give you everything, maybe they say at y equals 1, you have to plug in and solve for x, those kind of things. Okay, so let's go ahead and find the slope of this line. So we got to take derivative using implicit. Notice we've got 2x squared y, which is a product. So we have to start with product rule, which says the first which would be 2x squared, times derivative of the second. Derivative of y is dy dx, plus the second one, which is y, times derivative of the first. Derivative of 2x squared is 4x, minus derivative of y cubed is 3y squared dy dx, equals derivative of 7 is 0. So now, this one we are simply trying to find the slope at that point. So we don't have to simplify this down. We don't have to get a pretty equation for dy dx. We can go ahead and plug in. We're plugging in 2 for x and 1 for y. So we have 2 times 2 squared dy dx plus 1 times 4 times 2 minus 3 times 1 squared dy dx equals 0. 2 times 2 squared would be 8 dy dx, plus 4 times 2 would be 8, minus 3 dy dx, 0. Combine your dy dx's. 8 minus 3 gives you 5 dy dx. Move the 8 over, subtract 8. Now we just need to divide by 5. So the slope at this point for this curve is negative 8 over 5. Okay, we could then write a tangent line if we needed to, or whatever we needed to do for the function.